This is the second pattern that we see in connection with the microwave application. This emphasizes loosely coupled communication. We have two or more objects and they need to communicate. And how can you reduce the coupling that is needed when we communicate among them? That is the focus of this. So let's see about communicating in the context of the microwave. We had this microwave and clock. The clock is kind of a server. The microwave was a client in the initial implementation, and the clock knew explicitly about the microwave object. It had code like microwave.instance, and then it issued a method called clock ticked. So that server is kind of knowing exactly where the client is, what the methods of the client are, and this is not very extendable. This is not quite what works in practice. If you think about an online store from which maybe many of us purchase things, we are the clients and the store is the server. The store doesn't come to us and get information. Instead, we register with the store. We create accounts. We give them our credit card numbers. And whenever we need to purchase, we go to them and request. And when they have some specials, maybe they will inform us, right? So we could kind of borrow those ideas here. Like we set up an account with the online store, the listener, in this case, the microwave object, should be responsible for registering interest in getting clock ticks from the clock. So the clock can be more general. And if you think about the way online stores work, all they really care about is that the customer should have accounts and should have a valid credit card so that they will pay, right? They don't really care among the differences between the different customers. They should all have a common interface in the sense they should be people who can pay. Having a credit card stored at the server's website. So similarly, we can have, in the Java context, you can have multiple listeners of different types, but they should all satisfy a common interface. They should all implement a common interface, which can be the common factor for the server. And this common interface can have a method using which the server can send information to the listeners. And the sender obviously should have a mechanism for creating and maintaining a collection of the listeners that are interested in getting information from the server. And that is called the observer pattern. In the observer pattern, we have an observable, which is a single object, typically, and we have a number of observers. There could be multiple observers, and they are responsible for registering interest in the observable for whatever reason. So there should be a method in the observable that observers can call to register interest. And once the observer registers with the observable has a way of going through every observer and informing them of something that happens that might be of interest. This pattern has been implemented in Java, and that is called there is an observable class and an observer interface, but they have been deprecated. So we are not going to use that. Java recommends that we use two other entities. One is a class called property change support, and the other one is a interface called property change listener. So the observable, for example, the clock, would use this class property change support. And it would be used like an object adaptee. This would be the adaptee. And the observers, like the states of the microwave, would all implement property change listener. It has a single method called property change. And how does this work? How does the observer pattern work? Well, we said there is an observable. So this first object here, O, is the observable, and there are multiple observers, O1 and O2. I have shown two here. O is of type property change support, or it could be an object adapter. It is shown as a class adapter here, but it could be an object adapter. And here we are having O1, our first observer, implement property change listener. O2 also implements property change listener. And let's see what happens when something happens at the observable. So we assume that something interesting happened here, and it is written as a method called change state. So something important happened at the observable. For example, 1 second has elapsed, the clock has ticked, right? Then what the observable does is it goes through each observer, that is in this case there are only two, and calls the property change method of each observer. There is a method called property change in property change listener. If you look here, property change listener has one method called property change, which one parameter that describes what happened. That is the property change event. So the observable calls the property change method of the first observer with the event as a parameter. Something happens there and then control comes back. Then it calls the property change method of the second observer with the same parameter, control comes back, and things are done. So what happens, or what should be done programmatically in our application code, is to simply call this method fire property change, which is a method of property change support and with some parameters. This will take care of calling all these observers. I'm talking it from the viewpoint of application programming. In our code, we don't have to worry too much about calling everybody, we would simply fire the property change. It would take care of this. Calling the individual listeners.